Hello, everybody. We're the Trading Algorithm Group. My name is Aidan. I'm a finance and accounting major from Philadelphia, Pennsylvania.
Hey everyone, my name is Matthew Shawa. I'm from Basking Ridge, New Jersey. I'm a sophomore in the MSB studying accounting.
So, kind of looking at a high overview, like what is quantitative investing, which kind of what we dove into. So, quantitative investing is an investment strategy using mathematical models, statistical techniques, and computational algorithms to make decisions about buying and selling financial assets. Two well-known quantitative investing firms are Citadel Securities, Renaissance Technologies. Renaissance Technologies was a hedge fund that had an average yearly return of 66% net of fees from 1988 to 2021 using quant strategies. So obviously a very, very popular form of investing and a very powerful one. So kind of looking at different quant algorithms, we have statistical arbitrage, factor investing, high frequency trading, trend following, and mean reversion. The strategy that we created uses components of statistical arbitrage, momentum, and mean reversion. And most algorithms you'll see deployed kind of in a real world context will use combinations of different strategies in order to realize a strong return over time.
All right, great. Now we're going to take you through our collab notebook. Aiden's going to give a project overview, and then I will do a live demo, giving you guys kind of an example of how to use our code.
So looking kind of at our project overview, what we made was a momentum-based pairs trading model that was powered by the Alpha Advantage API and the Pandas package of Python. The way it runs is it takes two highly correlated assets return, and believes that they will return to the mean. And we seek to capitalize on the deviations in the stock price based on the 14-day moving average and standard deviation. So really quick, I want to just preface that this is automated strategy we developed. We developed backtesting procedures for it and ways to kind of test it and switch out uh, different z-scores, different standard deviations, and position sizes. But simply put, this works for a lot of strategies, but also doesn't work for a lot of strategies. So it's really important to kind of test these techniques, make sure the strategy you're putting in place works, and make sure that you have a significant understanding of our code and the kind of code behind quantitative investing, what to look for and what to not use. So simply put, use it at your own risk. We include a kind of Alpha Advantage API key at the bottom just to request a free API key through that link. And now Matt's going to kind of go through the project and run through our code with a live demo.
All right, great. Thanks, Aiden. Just getting into our notebook real quick. We have first section, gathering and cleaning the data. Like we said, we used our API key, which you're able to access at this link above. And we were able to generate these templates for the Alpha Advantage API. And we have three stocks that you could kind of look at a time. And as he mentioned, this is fully customizable. You can put any stock that you want in there. And just as a note, we decided to go with stock one and stock three. So those are going to be the ones that appear in the code later on in the notebook. Once we did our request, we got these data sets for each of the three stocks, and then we were able to use pandas to get the three different data frames. And finally, the end of our cleaning is that we merged them together and we dropped all of the rows except for the adjusted close volume or adjusted close price. So that was super important, and also converting the values in the data frame to numeric values that allowed us to do calculations with them. Now is the part where we check for correlation. The important thing here is that you're looking for two stocks with a relationship. We need to make sure that they're highly correlated, but not, perfectly correlated, in which case there will not be many opportunities for deviation from their price ratio. And we used borrowed a little bit of code from Professor Rossetti to get this Pearson correlation image. And this gave us the reason why we wanted to use the MicroStrategy stock along with the IBIT, which is a Bitcoin ETF. And again, correlation here, there's no one perfect number that you're looking for. It's just that you want to ensure that you're back testing, that you're getting two stocks that have some relationship and will have some sort of movement together. Now we're getting into the trading model. We first created this new column, which is the 1 day lag price ratio, which is simply dividing their adjusted close from yesterday, dividing the two stocks adjusted closes. And now what we did here is calculate a moving average ratio. Again, we made this customizable. You can change your window. You can make it, 3 weeks, 4 weeks. You can make it one day, 2 days. That's kind of up to you and your strategy. And like we said, we're using momentum strategy, so a shorter window was better for us. And we also included the moving standard deviation of this price ratio to add in some sort of threshold. In this step, we created our custom functions, which are our buy signals. This first one is our signal to buy stock one or short stock three. And so what we're looking at here is our price ratio in that day greater than the moving average ratio plus the z-score times the standard deviation? So is it a significant movement outside of that threshold, which would in turn say that you need to buy stock one and you should short stock three? And if that doesn't happen, then there's going to be no movement that day or no trading that day. Complete opposite here, buy stock three, short stock one, if your price average or if your price ratio that day is outside of the lower than the moving average ratio. Now, in this section, we calculated a return. We decided to go with a dollar return. And the way that we did that was find the difference between yesterday's price and today's price, which means, what you would have sold it for today minus what you bought it for yesterday. And calculating that return, we also did a cumulative return column, which allows you to see exactly what your total return is if you started day one, where you are right now. Just to finish up, here's our summary output. You're going to kind of get prices of both stocks. You're going to get what your buy signal is. Should I buy? Should I short? Should I do nothing? And then we also did a section here on all your returns, your win percentage on trading days, your loss, and your cumulative return. So for this example, had a cumulative return of over almost $208.
All right, so going back to reflections and just kind of talking very briefly. One thing I think I struggled with a lot during this project was dealing with a lot of errors. So we kind of went through our project. We had found some errors while like going in, and we had an original strategy which didn't work out. But then we had to kind of adjust based on that, try out different tickers, try out like different kind of correlations, and see what would work. That was a pretty difficult part of the presentation for us because we had a lot of difficulty calculating these returns, but eventually we were able to get that resolved, come up with a really great project that we can use over and over and over again as many times as we would like.
Something that I've been thinking about in terms of reflecting about this project is just the amount of the difficulty that we had researching, understanding this strategy because this was my first time being exposed to any sort of quantitative investment strategy and getting up to date on the lingo, what momentum means, what mean reversion means, all of that sort of stuff was a massive hurdle to get over. And that was the most important part was understanding it so that we could finally code it. But had a great time with this project. I hope that this was something that is informative to you guys, help you learn a little bit about quantitative investment strategies and also, how to implement something like this with Python. Thank you very much and have a great day.